Hi everyone, today we're going to be doing a very simple proof for why a system is linearly dependent if it has the zeroth vector. And it comes down to this very important point. Let's say it has some vector that goes out 0, 0, 0, and then to 1, negative 2, 3. Well, if I simply just subtract this vector from itself, and let's say I put orange on it, you're going to see that it's going to be the zeroth vector and equal to. That's the fundamental basis for this theorem. So let's express it mathematically. Assume we have a set that has v1 and v2. Okay, so a set that's comprised of these two vectors, okay? And assume these vectors to be in R3, and assume v1 is the zeroth vector in R3, so 0, 0, 0, and assume v2 to be some non-zero vector, or has some component to it. So I don't know, let's say a1, ax, ay, az. Okay, so where at least one of the a's has to be non-zero. Okay, well, can we express v1, any scalar multiple of v1, as v2? Okay, can this be true? Well, yeah, if for all k1, so any scalar multiple of v1, and that makes sense. If you multiply v1 by 1, 2, 3, 4, 5, you get out the zeroth vector every time. For all k1 v1, v2 v2 equals v1 if k2 equals 0, or if we could look at it as k2 v2 minus k2 v2 for all k2. And hopefully this just makes fundamental sense. It's a really easy theorem that was just a little confusing when you see it, because you're like, well, duh. Because your set is explicitly telling you that the zeroth vector is there, you cannot exclude the fact that you could just simply subtract the vectors together. As you can see with my Desmos here, I just add it, I have the vector itself, and then I subtract it by itself, you get back to zeroth. It means that, and all linear independence is saying that if a system is linearly independent, there's no repeated ideas. And the zeroth vector exists for any vector set because you can just subtract the vector, a real vector by itself, and you're going to get the zeroth vector, right? It's just redundancy in the system. So I hope that you guys enjoyed this video. Really simple proof here. If you did, please like, comment, subscribe, and have a wonderful day. Bye-bye.